Download this code from codegive.com, link in the description below. Ensuring all async operations complete before tests end, a comprehensive tutorial. Testing asynchronous code presents unique challenges. If your tests don't wait for asynchronous operations to finish, they might report success even though underlying tasks failed or produced incorrect results. This tutorial addresses the common problem of ensuring all asynchronous operations complete before your tests conclude, focusing on scenarios where you might encounter error 493, though this error number isn't universally standardized and its meaning depends on the context. We'll address the broader problem of incomplete async operations. This tutorial will cover several approaches using Python and common testing frameworks, pytest and unittest. We'll also discuss best practices for writing robust asynchronous tests. Understanding the problem. Async operations, like network requests or database queries, happen concurrently. If a test launches an async function and immediately exits, the async operation might still be in progress. This leads to flaky tests. Tests might pass sometimes and fail others depending on the speed of the async operation. Inaccurate results. The test might assert on incomplete or stale data. Resource leaks. Unclosed connections or unreleased resources can accumulate over time. 2. Solutions and code examples. We'll explore various techniques to ensure completion. A. Using asyncio.gather, for asyncio-based code. Asyncio.gather runs multiple asynchronous operations concurrently and waits for all of them to complete before returning. This is ideal for scenarios involving multiple independent async tasks within a single test. B. Using asyncio.wait, for more fine-grained control. Asyncio.wait provides more control over how you handle the completion of tasks. You can specify timeouts and handle exceptions individually. C. Using async with and context managers, for cleaner resource management. If your async operation involves acquiring and releasing resources, like database connections or network sockets, using async with ensures proper cleanup even if exceptions occur. D. Await within a test function, unittest and pytest. For simple cases where you have a single async operation, awaiting it directly within the test function is sufficient. Pytest requires @pytest.mark.asyncio decorator for this. Unittest requires using loop.run_until_complete. E. Testing frameworks and async support ****. Pytest ***. The pytest asyncio plugin simplifies asynchronous testing with pytest. The @pytest.mark.asyncio decorator designates a test as asynchronous. It automatically handles the event loop. *unittest*. The unittest.isolated asyncio test case provides a base class for writing asynchronous tests in the unittest framework. You need to explicitly manage the event loop using self.loop. 3. Best practices. 1. Explicitly await *. Always explicitly await asynchronous operations within your tests. Avoid implicit waiting or relying on implicit timing. 2. Use timeouts *. Set appropriate timeouts for your asynchronous operations to prevent tests from hanging indefinitely if something goes wrong. 3. Handle exceptions *. Catch and handle potential exceptions within your asynchronous operations. Failing tests should provide informative error messages. 4. Clear test structure *. Keep your asynchronous tests concise and well organized. Avoid excessive nesting or overly complex logic. 5. Test isolation *. Ensure that your tests don't interfere with each other. Use mechanisms provided by your testing framework to isolate the execution of individual tests. 6. Mocking *. For complex systems, consider using mocking to isolate your tests from external dependencies, databases, network services. 4. Addressing error 493, context dependent. Error 493 is not a standard HTTP or system error code. Its meaning depends entirely on the specific system or library you are using. If you encounter this error in the context of asynchronous operations, the core problem is likely the failure of an asynchronous task before the test completes. The strategies described above, using asyncio.gather, asyncio.wait, appropriate timeouts and exception handling, remain crucial for identifying the root cause and writing robust tests. Examine the error message carefully to determine the source of the problem. Debugging tools and logging can help pinpoint the failed async operation. By diligently applying these techniques and best practices, you can confidently write asynchronous tests that are reliable, accurate, and provide valuable feedback on the correctness of your asynchronous code, preventing issues related to seemingly mysterious errors like the context-dependent 493. Remember that debugging async code requires a slightly different mindset, focusing on the timing and ordering of operations. Careful logging and tracing will be your allies in identifying the source of any issues.